Alright, so here are the solutions to the statics worksheet. Question number 1 reads, the vector diagram below shows two concurrent forces A and B. Which vector diagram best represents the resultant force? So what we need to do is we need to combine both A and B in a way that we can see what is the resultant, or what's the result of those two forces. Well, we know we use the head-to-tail method. If we take force vector B and we add force vector A by the head-to-tail method, connecting the head of B to the tail of A, we can then draw a resultant force starting from the tail of B and going up to the head of A. We can label that now the resultant force. If we match it up with one of our answer choices, we see that choice number 3 is the answer. Okay, now with question number 2. The vector diagram below represents two concurrent forces. What is the magnitude of the resultant force? This is very similar to question number 1, but now they add magnitudes to the forces. To combine both forces, we start first with 1.5 newtons going in the right direction. We then add, using the head-to-tail method, the force vector going up, which is 2.0 newtons. And we connect them the same way as we did in problem number 1 to come up with our resultant force. Looking at this, we see that we have just formed a right triangle. So we can use our Pythagorean theorem. A squared plus B squared equals C squared. By inputting the information, 1.5 squared plus 2 squared equals C squared, we can see that C would equal the square root of 2.25 plus 4. Therefore, C would equal 2.5. If we match it up with our answers choices, we see that choice number 1 is the correct answer. Alright, now question number 3. The magnitude of the resultant of two concurrent forces is minimum when the angle between them is. Well, we discussed this in class yesterday. If we take two force vectors, we'll name this, let's say, A, and we'll name this B. The angle between them is approaching, or approximately, 180 degrees. If we were to use the head-to-tail method, and I'll do that over here, this is A, and this is B, you would see that the resultant would be a very small resultant. And as you approach more towards 180 degrees between the two vectors, the resultant will get smaller and smaller. Therefore, the answer to this question would be 180 degrees. Alright, question number 4 reads, a vector diagram below represents two forces acting concurrently on an object at point P. Okay, so I'm going to say that this is point P, and this is pretty much what we've been doing in the first 3 examples. We'll add this vector to that vector using the head-to-tail method. We'll draw our resultant coming from the tail of the original vector to the head of the second vector. We'll name it R, and we can match it up with one of our answers. We can see that the correct choice would then be choice 1. Alright, question number 5 reads, as the angle between two concurrent forces of 5 newtons and 7 newtons increases from 0 degrees to 180 degrees, the magnitude of their resultant changes from. Okay, so we can see at 0 degrees, I don't know what's happening here, let's see, okay, 0 degrees, we have 5 newtons, and 7 newtons. Together, they would produce a resultant of 12 newtons. So right away, we can see that it's either going to be choice number 3 or choice number 4. But what happens when it's 180 degrees? Well, I'll draw that here. If the 7 Newton force is going in that direction, and a 5 Newton force is going in this direction, then combined we can see that we have to do subtraction. 7 minus 5 would be 2. So when we look at our choices, 12 newtons at 0 degrees, 2 newtons at 180 degrees, our choice would then be 3. Alright, if we look at question number 6, a resultant force with magnitude of 20 newtons can be produced by 2 concurrent forces having magnitudes of. Well, the easiest way to do this problem is to look at our answers. Can any of those answers be put in a way that would produce a 20 newton resultant? Well, if we look at the first one, 10 and 5, if we were to put 10 newtons going to the right and 5 newtons going to the left, that would produce a 5 newton resultant. So that wouldn't be our answer. If we tried to put them in a different orientation, we wouldn't be able to manufacture a 20 newton resultant. So we know choice 1 has to be out. If we look at choice 2, 20 newtons and 20 newtons, could that be put in such a way? Well, if we think of it as 2 resultants, or 2 forces, with a 60-degree angle, that would produce a resultant of a 20 newton magnitude. Well, how's that possible? Well, if we had a 20 newton force and another 20 newton force, like I said, at a 60-degree angle, that would produce an equilateral triangle. Therefore, the resultant would have to be 20 newtons. So, choice number 2 is our answer. Looking at question number 7, the diagram below represents the force that could act concurrently with force A to produce force B. Which vector best represents the force that could act concurrently with force A to produce force B? Okay, so this question is asking, if we had force A and we added it to something, it would equal force B. Well, let's look at our choices. Could it be choice number 1? Well, if we had A and we added B, here's A, and let's say that this is C, would we get a resultant B? Well, that's our resultant. That would be our resultant B. And we can see that that doesn't equal the force of B. So let's look at choice number 2. If we had vector A and we added the answer, let's say C, that would produce a resultant B. Oh, sorry about that. B. Therefore, we can see that choice 2 would be our correct answer. Alright, looking at question number 8. 3 forces with magnitudes of 10 newtons, 8 newtons, and 6 newtons acted concurrently on an object, produced equilibrium. The resultant of the 6 newton and 8 newton force has a magnitude of. Well, in class we learned that equilibrium means that all the forces acting on an object would have to produce a net force of 0. So, if we have, we'll draw the picture of what's happening right now. That's an object P, and we have a 10 newton force, an 8 newton force, and a 6 newton force acting on the object. What would the resultant be of the 8 and the 6 newton force? Well, we know that the resultant would have to equal the third force vector. Because when it equals the third force vector, it would cancel that force vector out and create force net of equaling 0. Therefore, the 8 Newton plus the 6 Newton vector has to produce a resultant of 10 newtons. Therefore, our answer is 3. Just looking at this problem again, just so that you can fully understand, what we're saying is force net equals the resultant of the 8 Newton plus the 6 Newton minus the 10 Newton. In order for force net to be 0, because we know it's in equilibrium, we know that the resultant of the AN and the 6N have to produce 10. Therefore, 10 newtons minus 10 newtons would give us 0 newtons. Alright, question number 9 reads, what is the total number of components into which a single force can be resolved? Well, if we take a force vector, and we'll name it A, we can break A into its horizontal, AX, and its vertical components, AY. However, we see that A is the resultant of AY and AX. Now, we know a lot about resultants. We've been doing the head-to-tail method, and we see that any number of force vectors could produce a resultant A. Since it doesn't just have to be vertical and horizontal, we can see that there is an unlimited number of components that could make up a resultant or a single force vector. Therefore, our answer is number 1. Alright, looking at question number 10, the following diagram shows a person exerting a 300 Newton force on a handle of a shovel that makes an angle of 60 degrees with the horizontal ground. Calculate the magnitude of the components of the force perpendicular to the ground. Okay. Well, the big thing here is perpendicular to the ground. We know that a force vector is broken up into 2 components, a horizontal and a vertical component. And perpendicular means the vertical component which forms a right angle to the ground. Well, if we draw a figure, which is a 300 Newton force vector on the ground with a 60-degree angle, we know, I'll put in a different color, that the 2 components are f of x and f of y. In our case, we are only dealing with the perpendicular component, which is f of y. So we know that f of y equals F, which is our main force, in this case 300 newtons, times sine theta, which is 60 degrees. So substituting the information we know, 300 sine 60 equals 259.8 newtons.